That's it. Hi everyone, I'm Pony John, and I will probably be your new IA this semester. Today I'm going to give you a pretty straightforward, brief introduction on counting sort algorithm. So now let's get started. First of all, what is counting sort? Well, counting sort is one of the world's fastest sorting algorithms with a time complexity of O(n). The secret of its speed is that uh, it is implemented completely not based on comparison. Imagine the famous sorting algorithms we have heard of, like merging sort, pivot sort, or bubble sort. They are all based on comparing the element betwixt each other, so as to locate the right place to put the element. But if you want to implement a sorting algorithm based on comparing, every element in the array must be compared with at least one other element so that it can know where is the right place to put. Therefore, the time complexity of comparison algorithms must be larger or at least equal to O(n). But the speed of counting sort is exactly O(n). That's a quite magical speed. At the cost of some other restrictions. The input of counting sort should be always from a concrete finite set for it to work, because the basic working principle is based on counting. And now let's take a closer look at how is counting sort implemented. If you see the count array on the right, it is composed of elements from 0 to 5, and this is the elements that they're representing, and below them is a count of these elements. Well, to make it better to understand, let's think of voting for a state governor inside of Michigan. Well, yeah, for sure, we will have a Democrat guy, a Republican guy, and probably some other guys from smaller parties. And they're sitting imagine they're sitting here waiting for all of the people to vote. Initially, the votes or the count of the elements are all 0. And after this initialization is made, we're now making a simple pass from the start to the end. So let's go back to this numeric example. If we see a 4 here, what should we do now? We should go and confirm that 4 is in this count array. And after it's confirmed, we'll add 1 to the count of 4. And initially it's 0, and after we see the elements, it is 1. And then we go for the next element in the input array, it's 3. So we add 1 to the count of 3, and then 2, and then add 1 to 2. And so within a single pass of the input array, we can know that how many of from 0 to 5 respectively are present. And with such an information, we can reconstruct the array based on the counts, so that it is directly rewritten without any extra cost. So such kind of implementation is strictly O(n). And this is a very fast approach. Yeah, very interesting. But such a speed does not come at no cost, as I've mentioned before. So let me briefly discuss the pros and cons of counting sort. The pros is, of course, fast. time complexity O(n), it cannot be beaten by any other comparison source. But in most applications, we need to reconsider the pros and cons, and a lot of time people find that is its pros cannot overcome its cons. Because counting sort algorithm is not a in-place sort. It needs extra memory to build the count array. Well, if we scroll back to the slides before, yeah, we can see there is a count array from 0 to 5, and if we vote for a state governor, it should always be selected from several people. But imagine if the policy has changed and people could vote for everyone in the state for the state governor vote, and an assumption is made that everyone tends to vote for him or herself, so that every time the element is passed, it is not discovered in the count array, and we need to make a new bucket to hold it. So in such a case, the time complexity will be drastically huge. The count array is equal to or nearly equal to the size of the original input array, and it seems meaningless to do such kind of counting. And yeah, and that's a case that happens quite frequently. If we need to if we need to sort a bucket of floating numbers or strings, then exceeding extra memory would always be needed. So yeah, it fails with complex inputs. So in this sense, counting sort might not be that good. And this is all for today's session. Hope that you have now a better idea of counting sort algorithm and its pros and cons and how it can be used in real world applications. And thank you for listening.